I now have the pleasure to moderate the final session of this year's Climate Robotics Summit. And the idea with the session is to really build on all the incredible insights, and they've come from all directions. We've had such a massively multidisciplinary summit. So there's a lot to think about and discuss. And we're going to take those insights and think about what we might be able to envisage for the future of climate robotics, right? And that does not only mean the technology side of it, but also the non-technology aspects and dimensions, social, economic, political, environmental, and so on, that have basically been coming through very many of these sessions that we've had over the past 2 days. So with that, will let you know that I'm not seeing everybody just yet, but I will be joined by my colleagues, Professor Josie Hughes from EPFL, Stefano Mintchev from ETH Zurich, Berk Calli from WPI, and Professor Hsieh from UPenn. Thank you all very much for joining this concluding session. I will invite each of you to briefly introduce yourselves for a couple of minutes, and we'll then jump into some initial questions. And then invite everyone who is here with us to please chime in with your own questions. Please do post them in the chat here so that our excellent team leads can then highlight them during the Q&A. So now I'm going to look and see who might be with us already. I'm not seeing Josie just yet, but maybe we'll start in the order that I'm seeing you on my screen. So maybe Annie would love to give you the floor to introduce yourself and your connections to climate robotics.
Thank you so much, and thanks. It's an honor to be here and be invited as a member of the panel. My name is Hsieh. I'm an associate professor in the Department of Mechanical Engineering and Applied Mechanics here at the University of Pennsylvania. I also wear the hat of deputy director for the GRASP robotics lab here at UPenn. For those of you who are not familiar with GRASP, GRASP is the oldest interdisciplinary robotics lab in the world, actually. And so this is one of the sort of what's really special, right? Aside from the fact that we do lots of great work. My own research area lies at the intersection of teams of robots, ocean modeling, as well as distributed sensing, and we do a bit of scientific machine learning. And we've been doing this for over 10 years. We are slowly moving or expanding our research portfolio to not just think about trying to think building better ocean models, but thinking about better understanding our rivers and our waterways.
Thank you very much, Annie. Stefano, yeah.
Yeah, thanks, Patrick. Well, good evening, also everybody. It's a pleasure to be here. And yeah, so my name is Stefano Mintchev, and I'm the director of the Environmental Robotics Lab at ETH. So I started roughly 4 years ago to look at the intersection of robots and everything related to sustainability, climate change, and declining biodiversity. We do this by establishing very tight collaboration with ecologists and environmental scientists, and together with them, we develop and apply new robotics methods to better understand and also to also to protect nature. And we are very much focusing on aerial robots that we use for precision agriculture, but also for environmental monitoring and for biodiversity monitoring.
Thank you, brilliant. Thank you. Over to Berk.
Hello, everyone. I'm Berk from Worcester Polytechnic Institute, Robotics Engineering Department in the United States. We are a Manipulation and Environmental Robotics Lab and focusing on identifying environmental problems, establishing multidisciplinary partnerships, and developing robotic solutions. Some projects that we worked on were waste sorting for municipal waste recycling, ship breaking for metal scrap recovery for recycling, building envelope inspection for sustainable building stocks. And also we are looking for certain future areas like electric vehicle battery recycling and invasive aquatic species monitoring. Thank you.
Very good. Super. Thank you again all for being here with us. I'm going to ask a couple of questions. You're more than welcome to try to address both or choose one. It's been an incredible 2 days, and so open question: where do you see all this going forward? What can we expect? I'm not going to say in 10 years, but let's say in the next 3 years in the climate robotics space. So that's question number one, and then question number two. Given that your expertise is deeply obviously in the robotics side, I think one question that hasn't really come up maybe as much is what kind of breakthroughs do you feel are needed in the field of robotics to make this technology even more useful and impactful for climate action? So where do you see this going in the next 3 years, and what kind of breakthroughs do you think are needed in the field of robotics for climate action? Open. Chime in whenever you want. Anyone.
Oh, please go ahead, Annie.
Well, I was going to let you go ahead, Berk.
Sure. I really feel like this kind of network is very useful and needed to establish these partnerships and collaborations. And perhaps one thing that we can do is to make this as comprehensive, as open as possible. And that was the goal from the very beginning. And perhaps trying to come up with some organization chart, perhaps that goes to very grassroots approach to the students as much as possible, be as comprehensive as possible. Maybe have some regional hubs that connect to more like the international network, and maybe we can think about that part for the future. Another thing is that I really think that we can explore the possibility of having a peer-reviewed conference on this area. Maybe we can do that by the support of IEEE or other organizations. And we can make it very clear, like we accept papers, for example, that is only seeking for these convergent areas where environmental scientists, social scientists, and roboticists converge and be authors of the same papers. Just an idea that maybe we can discuss for the future. And very quick point, I just also want to say about the worker perspective. When there's robotics, there's always a worker component to it, right? And there are definitely certain areas that we heard in many cases that there are clear worker shortages in certain areas that then applying robotic solutions makes a lot of sense. However, there are certain areas that even though the job is dull, dirty, dangerous, they are the jobs that people are working right now. They are their livelihood. I think we can still talk about the worker perspective in certain areas and do not. For example, from an economist from MIT, Daron Acemoğlu, talks about how robotics and general automation, AI technologies affect the economy, while in certain cases accelerate the general economical growth, put people in a disadvantageous situations, especially when they are underprivileged. So there are, and this is supported with many data points. So I think we can also include the worker perspective in the discussion in the future. So an organization perhaps coming from more local to going to global, and conference, and maybe adding more worker perspective to the discussion. Thank you.
Very well put. Anyone, Annie, did you want to jump in?
Sure. So I was going to say that I think in the immediate future, right, and we're actually seeing a lot of this, and this was kind of born right through the other discussions, over the last 2 days. So we're seeing a lot more automation, autonomy, right, technologies moving into sort of, ground and aerial applications, agricultural robots and forestry, also potentially close to coast, right, applications. And so I think we're going to see more of that in the immediate future, and we're potentially going to see more adoption of those kinds of technologies. I think the thing that ends up being harder, and I think this, hopefully the people who are working in the marine space will sort of testify, right, is that some of these technologies becomes much harder to translate sort of into this underwater domain. And within the underwater domain, there's actually very unique, right, types of problems, right? If you want, this is a space that you need to have distributed sensing. But then when you do distributed sensing, you actually need to be able to find a way to communicate this data. And being able to do this in a way that has minimal ecological impact, right, is still very much an open problem. And this is particularly important for various reasons, right? From a physics perspective, right, the ocean ends up being sort of the primary heat sink and the heat transport mechanism around the globe. And so better understanding, right, the process, right, the role of the ocean within the entire climate system is extremely important. And so there is sort of components, and then being able to do that is going to allow us to do better forecasting. And this is going to impact our ability to do all kinds of whether it be aquaculture, whether it be restoration, whether it be search and rescue type applications. And so I think in the longer term, right, we will be seeing more and more things going into sort of that third domain, sort of the underwater domain. But I think it's still very challenging because this is a very wide domain, and even within, right, the oceans, there's different regimes, and depending on which regime you're talking about, some of the challenges are going to be harder, or some of the technologies that we already have on land and in air, may or may not translate as readily.
Very, very interesting. Thank you, Stefano. Yeah.
Yeah, so I think that you Patrick asked about the breakthrough that I kind of expect in climate robotics and what will happen in the next three years. So I think that the key word there for me is let's say the capacity that we have today to deploy robots everywhere and whenever is needed is not possible. So definitely we will make progress in terms of the autonomy and the resilience of this machine to operate in the wild, to perform very complex manipulation tasks. But this, I think, will happen gradually. Maybe it will take 5 or 10 years from now. So I think, however, that we can have very pragmatic solution that we can still employ, and we see that is already actually employed by many startups and companies, which is this idea of minimalism, and also let's say conceive our solution in a more modular way. So, for example, putting our sensor suits on backpack, on vehicles. So, and this possibility to keep the human in the loop is extremely important, because it also gives the opportunity to really integrate expertise and knowledge from local communities. So I see that finding this right balance between technology and human knowledge, local knowledge. So this is what would be extremely important for the next 3 years. And then gradually, of course, we imagine to build more and more, of course, also on the capacity of the robots.
Very, very good. Thank you so much, Stefano. Thanks for those insights as well. I have 2 other questions, but I want to see if there are any. I'm not seeing any questions yet from folks, but this is your chance now in the next minute. If you do have any questions for our speakers here, feel free to post them on Zoom. 2 very different questions. Humanoid robots. It's hard to avoid humanoid robots now, as of the past, 3-4 months. When I was talking to a VC last year, he was saying, yeah, just hype, right? And then a couple of weeks ago, I spoke to the same VC and I said, okay, what is your take now on humanoid robots? He's like, now it's interesting hype. So one question for you is, humanoid robotics and climate action, what are your honest thoughts on that? And then a second question, and feel free to choose or go with both. We've had many students join us during these past couple of days. So I want to bring back a question that I asked at the very start of the summit is, what advice do you have to students, specifically in your fields of robotics, engineering, and so on, who want to get into the climate robotics space? And I meet these students here at EPFL on a regular basis. They've told me, yeah, we can go into doing warehouse robotics for Amazon, or we can work with Stefano's group and eDNA aerial robotics, or with all of you here. So yeah, humanoid robots and advice for students who want to get into this space.
So I will try to answer this question of humanoid robots. I'm a horrible swimmer. I think the average person, is probably not a good swimmer compared to some of the animals that actually live in the ocean or live in the river. And so I guess that probably summarizes what I think about humanoid robots, at least in certain spaces for climate robotics. I think it really depends on sort of the task, right, that we're interested in doing. And so I think I'm going to leave it at that before I say something even more controversial. But in regards to, sort of advice for students, I think one thing that I like to say is that robotics is a, sort of field in service of another field, right? A robot has to, from our perspective, the reason why we build robots is because we want to try, we want those robots to be useful. We want them to serve a purpose. And in many ways, I think students have to, come with an open mind and a sense of humility. So in a lot of these cases, right, we often have to, be thinking about what the role of the robot is and how do we, design the best systems, right, to serve the purpose. And so you have to come with, sort of not just, an open mind, but you also have to come with an open heart, right, in order to be able to be a good listener and to be able to talk to, understand what the concerns of the stakeholders are in order to be able to come up with solutions, right, that actually make sense rather than sort of, solutions that is great for an academic exercise, but may potentially not find significant, sort of usage, right, or there's not going to be a pathway to transition.
Thank you so much for those points, Annie. Very well said. Stefano, Berk, Stefano, any?
I completely agree with Annie, and like it's not a coincidence that like while there has been very significant progress in the academia about like humanoid robots, it's not a coincidence that big leaps has been happening with these companies which has like virtually unlimited resources. So humanoid robotics is expensive, and it is definitely a very interesting research domain that pushes the state of the art further and further, asks very interesting technical robotics questions, and and in many times these like very impressive answers, but it is very resource hungry, and in the end it is probably it is hard to categorically say no to any solution, but it is probably a solution that we would think the most about before we roll any tangible outcomes. Thank you.
Thanks so much, Berk.
Yeah, maybe I can basically echo a bit what has been already said. So I think humanoid robots are, of course, it's a very exciting technological and scientific challenge. But if I think about humans and look at nature and all the diversity of shapes and behaviors that we have out there, I think that could be probably also, you know, other options that needs to be considered, especially for environmental system or for environmental robots. So yeah, I think we need just to be open-minded and decide task by task now what is the better options. And then for student, I can restate a bit what I said yesterday. Well, environmental robotics is really multidisciplinary, so you really need to be curious and be open-minded and be open to really you know, embrace completely other disciplines, and that's really, I think, extremely important if you want to jump into this field.
Very, very well put. Okay, we're getting to the end. So if you have a hot take that you'd like to share, something that's provocative, will make us think throughout the weekend, feel free to share it now. Just a quick one sentence. Again, no pressure. Anything that perspective, idea, opinion you had that maybe is not shared by the rest of the community that you are part of. Feel free to share, and we'll maybe go in the same order. Annie, if you have anything you want to share.
I think that's, you know, I think I said most of the things that, you know, I definitely think that we have to focus on the utility, right? And when I use the word utility, I'm using in a very, very broad sense, right? As to, you know, it could be for art, it could be, you know, for, you know, social purposes. But at the end of the day, I think if we're only focused on the robotics technology in a vacuum, right, without really thinking about the purpose of that robot, then I think we really miss an opportunity, right? To think about how to really extend the impact of the work that we're doing.
Right on. Stefano, any last words?
Yeah, that is definitely not only about the robotics. It's also about, of course, the people that are using these machines, their sustainability. And while these are all very complex aspects, require a very complex framework, and I think that hopefully this community that we are building can help basically to also build and provide really extremely valuable input to build this framework and vision.
Thank you, Stefano. Berk.
Sure. So I think the role of policy in bringing profit and solutions together has also been repeated multiple times in various different sessions and context. So I think we should also try to make an impact on that front. If we can leverage this kind of network, bringing many scientists, innovators, etc., together, I think we can also have we can make a strong point in the policy space as well. So in that respect, looking forward to the next Climate Robotics Summit.
Right on. Very well said. Thank you so much, Berk. Really appreciate it. This is really excited to be closing the summit with all of you. Thanks for your insights. I loved what I've heard, you know, from humility and open heart, open-minded, and just reaching out, and it's just music to my ears. So big thanks to all of you.